All right, so those of you, welcome. I guess I have to show you the board or it won't get you nowhere. This is what? Lecture number 3. We're in our second week. And it is what? The 24th. So, very good. Another thing you'll notice is if when you go to the home page. By the way, you gotta point. It's important you understand this. Maybe I'll just pull it up here. Let me. So when you go to the home page of, you guys should all be seeing it, whether you're here. On the right-hand side, I have the link to your lectures, the videos. And you'll see the syllabus, the homeworks, lecture slides, all that stuff. Right now, there's only been one home. Oh, I got to put the lecture stuff up. I apologize. I forgot to do that last week. If you guys, by the way, if you say like after class and things aren't posted yet and you want to see them right away, send me an email. Remind me. Because it takes a while. The lectures, they're not, the video's not ready immediately. It takes a while. Then I get an email from Zoom when it's ready. Then I have to upload it to YouTube. But at least the slides, I can usually have those up within the hour. So if you need them, please send me an email, harass me. All right, I'd be happy. I'm not going to be mad. And then I'll try to do that. So I told you guys last week that really the first 2 chapters of this book are, you know, I'm not so interested in like testing you on them per se. Like I'm not going to ask you test questions like, what is this or what is that? You need to read those things so that you're familiar with those terms when we use them throughout the rest of the semester. Like things like, okay, this is, you know, oh, this, I'm not going to test you on, is this a bar graph or is this a histogram or something like that? That's silly to me, right? Everybody has their own way of visualizing data and stuff, and I'm going to show you lots of different ways that I think are useful and important. But I am never, and I mean never, going to ask you weird questions like that on a test. We're going to ask you to do things like find data and then analyze it, or I'm going to give you data and have you analyze it. But I'm not going to give you like a multiple choice test that some of those words we talked about last class and a lot of the other terms and ideas that you should read about in the book. I'm not going to test you on them per se. Does that make any sense? So you're only going to get out of those chapters what you put in. As far as I know what this histogram is or a frequency chart or stuff like that. So we're going to ask you to do those things on, you know, I'll say make a history or histogram or make a frequency chart, but I'm not going to ask you to define those things. Does that make any sense? So the purpose of you reading that stuff in those chapters is more so that when you hear certain words later, you understand what they mean in a certain context. Is that clear? Okay, so that being said, let's go back to our whiteboard and let's talk about where we left off. We left off with homework 1, and homework 1 was, you know, a pretty straightforward thing. I don't deem it to be something that's of any difficult level. Does anybody have any questions they want to ask about number 1 before we sort of move on? I'd be happy to answer questions. I think it's due tonight at midnight, right? Something like that. Some of you have already submitted it. Does anybody have a question or comment? So you can either Google these words, things, write about them, or you can look them up in the book. That's up to you. I'm not going to sort of go over things that you can readily look up. We want to study the harder stuff, the math aspect of it. Okay, so
did you post a PDF for the book yet?
yeah, so if you go under the syllabus tab on the left-hand side of Canvas, you should see it.
All right, thank you.
Just don't tell the authorities, or I'll say you put it there. Just hack me, and you'll go to jail. Could you imagine? All right. Sometimes water tastes so damn good. I don't know what you do. Especially when you have your mask on all the time. Okay, so let's let's think about what the next homework's going to be about. As I said, what we're really concerned with is we're really being able to concern with how do we analyze data. And not only that, but if we're given data and someone has already analyzed it for us in a sense where they give us a picture or they give us a table, how do we make sense of that? Is the correct message being displayed? I mean, this is happening around us every freaking day now. We're in the middle of this epidemic, pandemic, whatever. You know, people are always giving you charts. The people who want you to think we're all going to die from the corona say, here's a chart that shows we're all going to die. The people who think it's fake says, here's a chart that shows you it's fake. They're all taking the numbers and data and they're skewing it in a way that makes their message what they want it to be. And what you should be as concerned citizens, not just about the corona, but about anything is that really what the numbers are saying? So there's an old phrase that says there's lies, there's damned lies, and there's statistics, right? And the reason we say that is because really, if I take any collection of data, I can probably make it look however I want it. And if someone's not educated properly, they're going to believe my data. Okay, so let's remember this. So let's recall the big goal of the class. First off, once we get data, maybe that's a bad way of writing it. So let's just say the big goals. Get data. Analyze data. And then
you can get off the screen with it.
The analysis.
What?
You guys please mute, por favor. I don't mean to be mean, but well, no, I'm just kidding. I'm never mean, but some other people probably don't want to hear it. So determine, not in, that makes no sense. Determine if the analysis is useful. So the way we thought about this last class is we thought about a problem where we wanted to know the average size of a male over the age of, no, what do you say males? We just said people, right? So we said the average size of any human on the planet over the age of 18. And we realized that if we wanted to get, if we wanted to do that, it's impractical to think that we can measure everybody over 18, right? And so we all agree then, okay, well, we can't do that, but we could still probably get useful information if we took some sort of randomized sample of that, what we call the population. So everybody over 18, we call the population. And then we said, well, let's take a sample. I think we used 100,000. Was that what we used maybe? I don't remember. 10,000, right? And we would call that a sample of the population. So say we go and get our data, then we would analyze it. But the question is, when we analyze those 10,000 samples, or what we call statistics, or data, if you will, how do we know that that is representative of the actual thing out there? Does that make sense? I mean, like I said, if just because you measure, say, 100 people in Pittsburgh, that doesn't mean that that's representative of the whole world, or even let alone Pennsylvania or the United States. Right? I'm sure if you look at some data for different cultures, the average height is different. So how do we get meaningful analysis? Questions about that? What was that?
Like say you go get your driver's license and they ask you for your height and weight at your driver's license center wherever you get a picture taken. Do they like maybe keep a record of those and then you can give a quote from
That's a
those?
good question. I don't know. Probably. I mean, that's all in a computer database somewhere. I like to think of it from a more practical thing. Say you make clothing. So you're a clothing manufacturer. Well, you can't just make 1,000 different sizes, everything. You have to sort of decide what do I want my clothes to look like and how should I size them, right? You're not going to you got to figure you're not going to make, the majority of your clothes aren't going to be triple extra larges, right? Or are they going to be extra small? So you have to, and then once you figure that out, you say, well, what is a small? What is a medium? What is a large type thing? I'm just using this as an example, right? So we have practical problems where, and there's lots of reasons you could say you want to do statistics. You might just want to do it for fun. Or you could think it as a practical reason, an application. Right now, people want to do statistics. Who are you going to vote for in November, right? How do we know that those polls make any sense? Every damn poll in the world said Hillary was going to smoke Trump 4 years ago, and then that ain't what happened, right? So what kind of crappy statistics were those people doing if they thought, right? So let's, for the sake of argument, let's just do another sort of a problem. We're not going to do 10,000 though. We're going to do something that we can actually sort of gravitate to. So let's motivate with a pretend experiment. So let's say we we are interested in how students did in math 1040 last term. So what I do is I take my grade book and get let's say the scores on the final. Now, so there are, I shouldn't say there were 30 students enrolled. So I could analyze them, all 30. Right? So we call all 30 the population. But to make the math easier, quote unquote, I'll sample 10 out of the 30. Right, so maybe I don't want to study 30 numbers. Maybe I just want to study 10 numbers. Does this make any sort of sense? Oh, nice, quick. So right now what you're seeing is, this is some software that we run some, I think I showed this the very first class. So what I'm going to do is I'm going to generate, I'm just going to generate 10 fake test score numbers. So I write a little code, and so here they are. So I wonder if I could copy and paste this. Probably not. Darn it. I got an idea. So what I did is I just had the computer give me 10 numbers. So let's write these down. So we randomly pick 10 scores on the final. So let's just list them. And what I'd like to do is we pick, the first one we get is 75.8%, 69%, 66.6%. I'm just rounding to the nearest tenth. 74.5%, 53%, 63.3%, 70.7%, 68.9%, 67%, and then 75. So we don't really know what randomly means, so I'm putting this in quotation. So imagine I took my grade book and I just, I put my finger and I moved it up and down, and when I stopped, whatever my finger was on, right? I don't know. Or maybe I rolled die or something. Who knows? Or maybe I just picked every other person. Who knows? It's that's another thing to consider. Are we biased? If I'm grading your exam and I know whose exam I'm grading, am I biased? Some of you I know, maybe I like you. Some of you I might not know. Or maybe I know you and I don't like you. Would I be biased? Random is a very tricky thing. We all in agreement with this, hopefully? Okay, so, cool. So no one's in the waiting room. Got to double check that. Okay, so what do I want to do with this? What can I do with it? Do I get any information? It looks to me like this test might have been hard. No one even looks like they got an A or a B, right? So last class, we talked about visualizing this, and we'll do some of that. For example, what I might do is I might say, okay, how many were between 0 and 50, and then 50 and 55, 55 and 60. I might try to think about frequencies of scores. So perhaps you construct a histogram or frequency table. So we're going to ask you to do this on the next homework. And of course, we'll do some of these together. But what I want to do now is introduce another idea, which is to actually examine the data numerically. So instead of that, instead of doing pictures, what we might want to do is we might want to measure things, quantify things. Perhaps the most basic way of measuring data is to compute its arithmetic mean, its average. It's a very common thing to do. Is it always useful? It could be. I mean, I gave you an example the first day of class of when the mean can be misleading. Remember I gave you a question. I said the average salary was blah. Should you take the job? The average, or the mean, or as we're going to call it, could be very, very misleading. However, it is important that in many cases, the mean is very illustrative of what's happening. And so it's something we need to be able to compute. So we need to define it. And so let's do that. So a common measure is called the mean. So this is the standard, and I don't know how many of you are familiar with other types of means, but there are other types of means. We'll study two in here, but this is the standard arithmetic mean. So add up the values and divide by total number. So we're going to remind you what that means again. Now, the first thing you should note is if we have 30 students, but you're only looking at 10, the first thing you ask is that really going to be the mean, right? And if so, or excuse me, if not, is it an accurate representation of the actual mean? Well, we don't know that because we didn't look at the other 20 students, right? We don't know. So we need to distinguish that we're not actually computing the population mean, for example. Just like on last week when we were talking about heights, if we only take 10,000 people, we don't know for sure that the 10,000 we select give us an actual representation. So we have to be very clear with that. And so this is where things like definitions come in, and we have to make sure that we understand differences. So let's do the math. And what I'm going to do is I'm going to, remind ourselves of what these numbers are. We need to add them up, right? So you could, obviously, if some of you might know Excel, this is real easy. You have a calculator. There's lots of ways you can do this. I will teach you different ways of doing it. What I'm going to do is I'm going to minimize this, and I'm going to do it for you on the computer. So what I could do is I can say, okay, if I come back here, I can now add them up. So the way the computer does this real quick, if I just do, if I do sum of A, what it's going to do, I'm going to call this something. I'll call it numerator. So what this is equivalent to you going to your calculator and adding all these 10 numbers up. So when we do that, we get 685.7. Now, what is the mean? The mean is you add all the numbers up and divide by how many. So now I have to take this, my mean is going to be equal, I'll just call it, I'll call it mean. Mean is going to be equal to the numerator divided by 10, because that's how many numbers I had. No, you're not supposed to be seeing Excel. Right now, you should be seeing a whiteboard, and then now you should be seeing, actually, it doesn't matter if you see what I'm seeing. I'm using a calculator right now. And we're going to go back to the whiteboard in a second. Okay, so when I hit this, now I get my mean is 68.57. Which you could have easily done in your head because dividing by 10 is the same as moving the decimal point over 1. So look, we're going to write this down in a second. Let's go back here and let's be very clear on how I'm doing this. Move this here and go to the next page. So the typical way we define mean is we define it like this, with a symbol we use. So the mean is defined by X with a line over it. This is read X bar. And it is equal to these numbers. So it's 75.8 plus 69.0 there, plus 66.6. Now I'm not going to write them all in because it takes up too much space, but it goes all the way down to, what was it, 75.9, right? And then I'm taking those numbers and I am dividing them by 10. And when I add that up and divide by 10, I got 68.57. Oops. Now, of course, if you use a calculator and do this on your own, you might get a slightly different decimal because you may have rounded different. We didn't talk about rounding or anything. But you may get something different. You may get 68.8 or who knows. It just depends on how you round. But and you should try to do this on your own and verify. Does anybody have a question about this? So some terminology. So we call X bar the sample mean. Why? Because we sample 10 scores from a population of 30. Does anybody have a comment or a question about this? So here's where we start to distinguish things. So I'm going to make a line right here. This is very important we understand this. So if if we took all 30 scores and computed the mean, we call this number the population mean. So again, the population means we compute the average of every single person involved, or every single item involved, depending on what we're studying. The sample mean says we take a subset or a portion of the total population and look at that. Questions, comments, concerns? We got to make a definition. Oh, someone's chatting. Yes, there is. I'm going to show you that right now, Khadijah. Katie, I got you. See? So here's where the maths, here's where the symbols, we sort of lulled you in with some hopefully intuitive ideas, but now we have to write down some math. And this is sort of where things get scary for some of you. So one of the things we have to use is we have to use subscripts. A lot of students don't like subscripts. You get afraid. But the problem is we can't just use a different letter for each thing, because imagine there's more than 26 things we're studying. Like with 30 tests, test 1, what do I want to call it? What do I want to call it? Score 2, score 3, score 4, whatever. If I'm studying heights, height 1, height 2, height 3, height 4. Well, if there's 10,000 heights I'm going to study, how can I label that effectively? So what we typically do is we do the following. So this is very scary, but this is how we do it. Definition. Let there be N, capital N. So here we go. We're going to have lots of letters. And I feel bad because this gets scary, but it is what it is. We have to sort of hold on tight, I guess is the way of doing it. Okay, so what would we call N? We're going to leave, what we're going to do right now is we're going to leave our little pretend problem of scores. And we want to go to making a definition that applies to anything that we're studying. Ooh. I thought there was some place I could put my foot. Open it up, and now I do. This is good. So what would N be? So if we go back to our example, N, so what would be my 30? That would be my population, right? So 30 is my population, the number in my population. 10 was the number in my sample. So let capital N be, oh, upside down. Wrote that wrong. So let capital N be the number of sort of values in your population. So if it was the height example from last class, well, how many people on this planet are over 18 years old? That'd be hard to quantify, right? Maybe we round to something like 5 billion. I don't know. What's the population? Who knows? But in this other example, it's easy. It's 30, right? It's not hard to see another issue here. How do we, when things are impossible to calculate, what do we do? That's another problem we have to think about. So let there be N values in our population. I guess I should. I hate hyphen. And now this is going to be frightening. Let there be lowercase n, which has to clearly be less than or equal to capital N. Let there be this many values in a given sample. So we need generic names for these. What are we going to denote them? So let's denote them. X of 1, X of 2, this subscript thing, X of 3, then that goes all the way up to say, okay, this is going to look real scary. This will be X of n minus 1, comma, X of n. And then it's possible that this keeps going up to capital or X sub capital N. So let's sort of annotate this so you kind of understand what we're saying here. The first N of them, this is my sample. And then all of them is the population. So if you imagine what you could do is if you go and collect data, if it's a bunch of numbers, remember these X sub n's are numbers, right? We're not talking about, I mean, we used this word last class. We talked about, we talked about qualitative and quantitative. What's the difference? Well, if we're talking about names of states, you can't take the average of the name of states. Think of context here. These X sub 1s and 2s and 3s, they have to be numbers, right? And you can imagine then that you could lay them out, right? If you're going to take 10 test scores, you can lay those numbers out, and you can put them in order if you wanted, from highest to lowest, lowest to highest. You can do them in any way you want, right? But you can list them. That's what we're saying. You can list them. And we're going to call the first one X sub 1, because that's just the convention. It's the easiest way for us to do this. If you find a better way of notating this, then you'll be famous. For the last couple hundred years, we've figured out this is the best way to do it. X sub 2, X sub 3. Now, this usually looks scary, you know, because you're like, oh, what does that mean? Well, imagine if little n is 10. What is n minus 1? 9, right? So it's the number that comes before n. And then what comes after n? That would be 10 plus 1, or 11. Does that make sense? Okay, so here's where the fun begins. Now we want to define these sort of what we call means. So the sample mean is X bar, and that is the sum of the first up to X some lowercase n, and you're going to divide that by little n. And then, Katie, this is where your question comes in. What is the population mean? Well, the population mean we denote with the Greek letter mu. And this says you add up not just up to lowercase n, but you add all of the population up. Now, there is a shorthand for this that you need to get accustomed to. You often see this when you look it up. There's a shorthand for some of you know this already, pardon the pun. We use the Greek letter sigma to illustrate we are summing things up. So this is going to be something that you guys are going to have to get accustomed to. And of course, some of you know these things already, some of you don't. We'll use a different letter here. So this is, we're throwing a lot at you. Some of you have seen this before. Those of you who took calculus have seen this notation before. If you haven't, that's okay. You're seeing it now. Welcome. Parlez-vous français? Oui, oui, oui. Sprechen Sie Deutsch, right? It's like a new language. There you go. Anybody here sprechen Sie Deutsch? Or what's parlez-vous français? I speak French. And then habla español. I speak Spanish. Well, drop me off anywhere. I'm surviving. I don't know what the hell I'm doing up here. So this is scary looking, right? Let me annotate this again for those of you who don't know. This is right here. This is the Greek letter mu. It looks like a U, but it's kind of got this little tail in front of it. And this is the Greek sigma. And it means sum or add up. Lots happening, huh? All right, we having fun? So here's some questions you want to think about. For example, how big of a sample do you need to get an accurate description of your actual population? You know, think of a problem where the population's impractical to study. In our example today, we could study 30. We could have easily done that, right? But in the problem of last week, there's no way we can investigate every single human being over the age of 18. It would be impossible. Question is, how many do we need? How do we know that's all we need? These are hard questions to answer. We sure as heck ain't going to answer them in Math 1040 at La Roche University. Okay? There's people sitting in offices down at Carnegie Mellon right now and at Pitt and at all these big universities or working at big banks that know that you can't always answer these questions, right? But there's ways that we can try to get good information, even if we can't. Get information for everything, I guess is a better way of saying it. Here's some more terminology that seems like we're really throwing at you. So we call X bar a statistic. We call mu a parameter. So these are words that you will likely see again. Again, I'm not going to ask you to define it on a test. I'm not going to say define parameter. I'm not going to say define statistic, but you have to get with the lingo. It's like, you know, if you want to be good at this and learn this, you have to be accustomed to the words that are used by people who speak this language. It's just like, you guys know this. You some words you can say in one culture that you really can't say in another culture. Or, you know, some word you might be able to say in the United States, if you say the same word in another country, it might be derogatory or vice versa. So you have to learn these, the context of things. So we need to know what context we're in. What is it? What is a parameter? What is a statistic? These are things that are important to know. Does anybody have a comment or a question? I'm like leaning in, like I'm on like some like call here. Like I'm like, hey now, what's going on, bros? I shouldn't say that. Now, why do we distinguish these two things? Well, it's clear to us, we think at least, that we can always get a sample. So we can always compute X bar. We don't know if it's useful or not from case to case, but we can always compute it. But a parameter is something we can't always compute. Theoretically, it's out there somewhere, but how do we compute it? Does that make sense? Like, there is an actual mu for the average height of adults over the age of 18 on this planet. But even though it's theoretically there, theoretically, if we were some creative way, we can measure the height at one instance of everybody over the age of 18, add them all up and divide by the total number. Theoretically, but is it practical? No way. Right? So that's why we distinguish these things. Something that we can actually get our hands on is what we're going to call a statistic. And if it's something that's theoretically there, we'll call it a parameter. So our job then, if we're thinking about it, and this is going to be a theme I'd like for you to ponder, is the job of computing X bar in determining what sample size you need. There's a whole branch of math that we're even introducing you to. It's called the idea of estimating parameters. How do we estimate? I mean, that's our goal, right? If we can't measure the height of everybody, well, we need to figure out what value of n is sufficient so that we've estimated the true mean, the parameter mu. There's a whole branch of science, it's called estimation theory, that people do this stuff. Anybody have a question? So there's all kinds of conventions that I hope you'll read about when it comes to rounding. You notice I breezed over that when we did our example. I just kind of rounded to the nearest 10th. But should I round it to the nearest 10th? Maybe I should have went to the nearest 100th, right? What are the conventions for rounding? Everybody has their own conventions. Physicists, engineering, chemists, biologists. Think about the differences too. I mean, if I'm reading a gauge, maybe I'm trying to understand the pressure of some container for a bunch of containers, and I have to read a gauge. Well, my interpretation of the gauge might be slightly different than yours. That might be a rounding error. Or maybe we're measuring or trying to understand support systems for a bridge or a skyscraper, say metal beams. When I use a certain measuring device, I may interpret it different than someone else. So all these other things really come into play too. And maybe you don't think of these things, but you need, you know, if you want to make good use of things, you need to think about elements such as human error. All right, fair enough. So that might be something you want to, do as well. And then there's all kinds of shortcuts you can learn. I mean, you learn about this thing in algebra called the distributive law and factoring, and that can be very useful for helping you to find averages if you have your things grouped. If you have things grouped into different frequencies, then you don't have to add everything up. You just add up this in this frequency, multiply it by the common, and then how many there are, and then do the same thing. It's all kind of shortcuts you can learn and do. Okay. Very important thing. Do not confuse mean, either one, with a word that's very similar, which is called the median. This is very important. What is the median? The median is the midpoint. So it can mean one of two things. If you have an odd number of data, it's the one in the middle. If you have an even number, then that doesn't make any sense. You have to take the two that you would say are in the middle and average them. So there's two cases here. By the way, before I write that down, does anybody have a question about that? What I mean? So if you take your data and you, like I said, you have a list of numbers, you can write them in any order you want. Say you put them in a natural, lowest to highest. Well, then you take the one that's in the middle. Well, that only makes sense if there's an odd number of entries. Right? If you have an even number, that doesn't make sense. So how do we adjust that? Yeah, so you add, well, you got to be careful. What do you add up? What is the formula for this? Is there a mathematical formula? So it turns out you could actually write a formula down for the median, but it's very convoluted. It requires some weird functions. So we're not going to do that. The best way to understand how to compute it is to look at a list or a specific example. So let's actually, maybe we'll rephrase this so it's not so, it might be misleading what we're doing here. Oh, sorry, wrong button. So this means let me put it this way. So this means arrange your values, your data, in ascending or descending order. If you have an odd number of values, the midpoint is obvious. And I don't mean obvious like ha ha ha, if you don't get it, you're not paying attention. But if you just list a bunch of numbers and there's a total odd of them and you put them in order, it's going to be clear to you what the middle number is. There's not much thought there. If it's even, you take the average of what I'll write as the middle 2. So this is best. This is easy, or I shouldn't say it's best, but the cleanest way to see this is to just do an example. So let's say we have, let's use obvious. Let's say 1, 2, 3, 3, 6, 8, 12. So note that there are how many terms here? Actually, let's make it a little more interesting. How about 15 and then 20? So there's 9 terms. Which one is in the middle? So this would be the median. So if instead, though, I had maybe the list that I just modified slightly, what if instead I had this? So suppose there's some other number here, then the median is now, you take the middle 2. Well, there's 4 before these guys and 4 after, so the median equals 6 plus 8 over 2, which of course is 7. So this, if you think about it, this will give you a much different sort of quantitative value than the median, the mean could. So if you go back to that example I suggested on the first day of class, where you have this average, the mean salary at some company is blah, well, you could think of many examples where the mean and the median aren't anywhere near each other. So you should play around with that. That's the best way to learn. You know, pretend you're in a sandbox, get your hands dirty. Or not. That's what my kids do. This, I always think about, I tell this to all my classes, you're gonna hear a lot of it because that's just what it is. It gives you a different perspective of how humans learn when you watch kids learn. Because they learn everything by experience, by doing. Which means that just screams to me that that's the best way for us to learn, by doing, which is kind of funny that we're sitting here, you're watching me, right? It's like you don't go, you know, in sports, you know, it's not like they sit around and watch the coach do anything, right? I guess my job is to motivate you and maybe make you excited to learn this, but if you don't want to learn it, then there's nothing I can do. Have I told you guys that I loved you yet today, platonically? I think one of these days this semester, I'll dress appropriately. I'll wear like a collared shirt. Do you think I should do that one day? Yeah. I have a bunch of these. I have lots of Wu-Tangs. I make my own shirts now. People always comment on it.
What's the equation?
There's not an equation. This is called, so the pun on this shirt is in a branch of math called linear algebra. There is this thing, some of you might know what a matrix is. A matrix is an array of numbers. And it turns out they're very important in many real-world problems. And when you're trying to solve problems with matrices, the goal, what makes them real easy to work with, is if you can rewrite it as a diagonal matrix. That would mean numbers down the diagonal, zeros elsewhere. Sometimes you can do that, sometimes you can't. Right? So, but you can always do it almost like that. What you can always do is you can write it as numbers down the diagonal, zeros everywhere, and then perhaps ones right here. And the mathematician who is credited with this discovery, his last name is Jordan. So this is called the Jordan form of a matrix. So I saw a couple of years ago on the internet, someone had a picture of this matrix and called it the Jordan form that had the jump man there. And I said, that's great, but I can do it even better. So what the thing at the bottom is what's called, this is called a minimal polynomial. You remember the word polynomial. So what's important about this is if you take this matrix and plug it into this equation, it spits out 0. Now you're going to say, how do you plug a matrix into an equation? Well, you can. And it's not hard. If you take certain classes, you'll learn that. For example, Anthony, you will take linear algebra. We'll even talk about that a little bit in discrete math. It's a very important thing for solving problems. Google search engine is based off of a problem that is using this as a solution. So many algorithms in computer science, prob and stats, matrices are very, very important. There's something you may have heard of before. Let me share it because it's fun to do this. And this is good. You ask a question, we get to learn. So let me go to this. There's a thing called a Markov process. It's very, very important. And it's used in many applications from biology to finance and blah, blah, blah. And blah, 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 blah. Anyhow, you read about this and you'll see that there's probability involved and there's things that we're going to learn some basic stuff. This is very high level, but they use matrices to solve very difficult problems. You'll see there's matrices down here. And by the way, it's worth pointing out, if you're interested in learning, you just Google the Jordan normal form. And you can read all about it. So if someone was in the know, if you look at my shirt, the red Jumpmans would be the number 23. And then the black Jumpmans would be the number 45. So for this to make sense. But no one gets that, but a bunch of math nerds who happen to like sports, which is very few. I'm one of them. Then I have the other ones with the Wu-Tang. I had a good one for 4th of July. It really made a lot of people mad because I had a Wu-Tang symbol that would represent the number 1776. And then also one for what amendment was, we should know. What amendment is that? Was it 1865? I think it's, yeah, that's right. The 13th Amendment when the abolition, when slavery was abolished. So you wear that shirt, people say, what's that mean? And then you say, oh, damn, and I wore it on the 4th of July. That pisses people off. There's nothing better than making people mad, especially when the way they think they're only mad because they're mad that they just get punked. I like to do that. You guys notice. You sat with me through all last semester. Then why would you wear that? The 4th of July. I said, is it though? Hypocrisy is the #1 thing I like to point out. Now, man, I love pointing it out. I got to look at you guys too. I just love to point out hypocrisy. It gets people really mad. You know, it's funny. So going back, speaking of the last thing, see where you got us right now? Damn, Connellsville got us all the more. But speaking of hypocrisy, I love this. Like, we'll go back. These are Greek letters. Mu is a Greek letter. X is a Roman letter. The Romans, and then these numbers are the Arabic and Hindu numerals. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let that sink in. And it's like Nas told us on his album that came out last Friday. Can you imagine how you would have thought differently in school with math if you were certain people from certain areas and you realized where it was actually discovered, right? Who invented numbers? Who invented algebra? Who invented all this? We mislead on who did all this stuff. Where was it invented? It sure as hell wasn't invented in Pennsylvania, right? Anyhow, I like to point these things out, make you think. If anything, you might not even agree with me, but it might make you think. And then maybe you go home and learn something. We talked about a lot of stuff. I've insulted a lot of cultures already. This is good. This is what I do best. Make you think. All right, good stuff. So that's the median. And some people demote it like MD or something. I just write it out, median. Sometimes it's useful, sometimes it's not. The mean is sometimes useful, sometimes it's not. The mean, here's 2 great examples to understand when mean is useful and mean isn't. We would imagine that the mean is useful when studying the heights of adults. We would imagine that. And the reason I say that is because there's not many, think about it, it's a very good description of what we would see. Think about it if you made a histogram of heights. It would look very much everything would be blumped in the middle, right? Does that make sense? I mean, most people are around, there's very few people that are 7 foot tall, and there's very few people that are adults that are 3 foot tall, right? That's very rare. Most people are somewhere, 5.5 to 6 feet. That makes sense to us. Now, if you looked at the distribution of wealth in this world, that ain't gonna look like that. Most people, distribution, almost all the world's wealth is held by a very small group of people. So instead of it looking like, let me draw a picture. And you can Google this if you want. So this is something that I would encourage you to think about. So these are examples to ponder. When mean, median might be useful, not useful. So you can Google this and study this more, but if you looked at the distribution of heights of adults, if you drew it on a number line and drew it, let's imagine that it's somewhere going to be like, the heights are, there's very few small people, but it's going to look like something like, let's just say, for example, this is 3, and then 4, and then 5, and then 6, and then 7 feet, right? Well, you would imagine if we maybe make some sort of like histogram, if we will, you would imagine like almost all of it's going to be concentrated between 5 and 6 feet. Then there's going to be a fair amount of people here. There's not going to be hardly anybody over here. And then there's going to be maybe a fair amount of people in here, and then there's hardly going to be anybody in here. Does this make sense? So I guess maybe we'll add, I don't know, is there many people over 8 feet? I don't know. Does this make sense what I'm saying? At least I'm just sketching this, but I hope it makes sense. And so if you went and took the means of a bunch of people and their height, it would match, this is what would match the picture. Everything's concentrated in a certain place. However, if you decided to go Google distribution of wealth, well, it ain't gonna look like this, right? Very few people on this planet have the majority of the wealth. So what would a picture like that look like if you just had to use your imagination? Well, you would imagine it's going to look something like this if you read left to right. I'm hitting the wrong damn. What is wrong with me? It's going to look more like this. So if this axis is, say, I don't know, what's a good way to draw it so that it's illustrative? Let's say it would probably look something, let's say probably, I know what it's going to look like. We'll just pick it up and, come on, I keep hitting the mouse. It's going to look something like this, where small, 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 small. It's getting a little bigger. It's getting a little bigger, getting a little bigger, getting a little bigger, getting a little bigger. Getting a little bigger, 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 getting a little bigger. Then it might start to grow a little more. And then all of a sudden, it shoots up. Something like this. So what do we mean by that? Like, so let's add sort of an or y-axis to this. So you can imagine that you can call this your net worth. Like, what are you worth? Most of you in this room, and myself included, we ain't worth anything positive right now, right? I mean, I have a mortgage. I don't own my house yet. I have equity in it, but I don't own it. I still pay. So most people don't even have worth. Most people have car payments and rent payments and house payments. Very few people are living on the other side of that. Right? You guys will have student loan payments for the most part. We understand what I'm saying here? So if you went and took the average of everybody's wealth, it's not going to be represented by this picture. Because it's really, really, really skewed because a small percentage of the people on this planet hold all the money. And I'm not saying that in like a political way, like we got to be socialists or something. I'm just saying it in an actual data way. I'm not suggesting that the world's crooked. Maybe we could get about those philosophical conversations at another time. The point of the matter is it's concentrated in one place. Not in the middle, but way at the end. Does that make sense? You know, so if you would think about worth, there's very few, if we would add like, you know, you're really not even thinking about people that have, down here, you're looking at maybe like 100,000 people. Or excuse me, $100,000. And then, you know, really, even people that might have, you know, 1 million. Almost all of us are in the negative. Not in the negative, but you get what I'm saying. Most people aren't worth $50,000. Some of you hope to one day be worth money. You hope to one day pay off your home or your whatever, and you hope to have equity and stuff. You might have money in the stock market or retirement. You take everything that you have and you subtract off what you owe to everybody else, and that's your worth. And this is how it's distributed. You can do the research on your own. Anyhow, we got to go. This was fun. This is something to ponder about mean and median and when it might be useful and when it's not. All right, guys, listen, you have a great one. I appreciate you guys coming along for the ride. I will see you guys Thursday. Take care.